Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to be looking at sequences, specifically how to write the equation of a sequence given a sequence of numbers. So to give the basic outline of what we're going to be doing today, if I have a sequence of numbers such as 2, 4, 6, 8, 10, I want to know what's the equation for these numbers. So the first pattern I notice here is that the numbers are going up plus 2 each time. And whenever you have this as the pattern, plus or minus some number every time, then the formula is going to look like this. In this case, 2 times n, because we're going up by 2 each time, and then plus some constant. Now, one thing I'm going to say, for all the sequences that I'm going to do, I'm going to be starting at n equals 1. Although this is not always the case, I've seen other teachers start at 0, for instance, but I'm going to be starting at 1. And so, for instance, if it was going up by 4 each time, it would be 4n plus some constant. And if we were going down by 1 each time, it would be negative n plus c. But now I still got to solve plus c. And to do that, I got to think about where my numbers are starting. So for instance, if I plug in n equals 1, 2 times 1 is 2, which is my first number. So in other words, I think c equals 0. And for instance, if I plug in the second term when n is 2, 2 times 2 is 4, that is my second term, 4. Looks like the constant there is 0. So the answer for this one is just 2n. Here's the next type of example we might be looking at. The sequence is 2, 6, 18, 54, As you can see, what's the pattern here? It's times 3 each time. And whenever you have times 3 each time, the formula is going to be c times 3 to the nth power. Or again, c is the constant that makes my numbers work out. But because it's times 3 each time, it's 3 to the n. If this was times 9/4 or something each time, like a weird fraction, then it would be 9/4 to the n power. And to find c, all I got to do is plug in that first term, n equals 1. When n equals 1, I want to get 2. So 2 has to equal c times 3 to the 1. In other words, 2 equals 3c. Divide both sides by 3. c equals 2/3. And the resultant sequence is 2/3 times 3 to the n. And there we go. That's it for the second type of sequence we might see. The third type of sequence might look something like this. 0, 3, 8, 15, 24, As you can see, this one has an interesting pattern. It's plus 3, plus 5, plus 7, plus 9. We can see where this is going. And there is an algorithm to find out exactly what this formula is, but I'm going to show you a shortcut for this one. And so the shortcut is, if you see the number is going up by 2 or whatever each time, it's probably because it has something to do with the number squared. What do I mean? See how all of these numbers are almost perfect squares? For instance, let me just write a list of random numbers right below, and let me tell you how these numbers are related. These are the perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And the list above is that exact same list, but minus 1. In other words, the blue list is the sequence n squared, and the black sequence, the one I want, is n squared minus 1, and that's going to be our answer for that one. And then the only other kind of sequence that I want to warn you about, if we have something that alternates, like 1, negative 1, positive 1, negative 1, and technically these can be any numbers, but 1 is the easiest. Whenever you have an alternating aspect to it, the answer is either negative 1 to the n or negative 1 to the n plus 1. How do I know which? Well, if I'm starting at n equals 1, looking at my left picture, that will be a negative for the first number. It would be negative 1 for the first number. But if I look at my right one, 1 plus 1 is 2. Negative 1 squared is a positive. So, in other words, you use this one if the first term is negative, and use this version if the first term is positive. And by the way, a lot of people I see also write this and minus 1. It's the exact same thing. I don't care which one you write, but you can see both potentially. And if the alternating part was part of another sequence, like for instance, if I already had the sequence 3 to the n, but I'm saying it's alternating, then just put the -1 to the n plus 1. If it starts with a positive, just put that in front of the other pattern you noticed. And that's how you deal with the alternating aspect. And like this together is the total answer, and you really can't combine that too much. So instead, let's look at some practice problems so we can boost our understanding. For all of these practice problems, I want you to try them on your own first, and then watch the video if you need the solution. So for this first one, it's 3, 2, 1, 0, -1, ... What is the sequence? Pause the video, try and figure it out. And here's the solution. So I notice that these numbers are going down by 1 each time, which means that immediately I know it's -n plus some constant. And to figure out what the constant is, I got to check out my first number, if n equals 1. Because if n equals 1, that's -1 plus c, and I want it to be 3, because that's my first term. So add 1 to both sides, c equals 4. So my final answer is -n plus 4, and that's it. Here's the next one. It's going to be a fraction, 1/2, 2/4, 3/8, 4/16, ... Now I want to give 2 hints for this one before you start it. Number 1, I know some of these fractions can be reduced. Do not reduce them. There's a reason why I wrote them like this. My second hint to you is there's a separate rule for the numerator and denominator. Figure out both, divide them by each other, and that will be your answer. So go ahead, give this a try. And here's the solution. So for the top, we notice it's +1 each time, and the bottom one is ×2 each time. Which means for my numerator, it's 1n plus c, the constant. Denominator is ×2, so 2 to the n, but with some constant c out in front. These c's might be different from each other, so maybe I even want to use a different letter, like k or d or whatever variable you want to use. And to figure out what these variables are, I just have to think about what my first term needs to be. For instance, when I plug in 1 for n, that gets me 1 plus c. I want a 1 for my numerator, meaning that c can just be 0. I'm good with my numerator just being n. So c equals 0, numerator is just n. To figure out the denominator, same idea. Plug in 1 for n, that's 2 to the first, 2. I want the first term to be 2. I'm happy. Looks like k is just 1. And therefore my final answer is n over 2 to the n, and that's it. And now for the third and final example today. This will be a challenge question. I think most of you will get it wrong, but give it a try. The sequence is 4, -9, 16, -25, +36, ... Okay, so go ahead, give it a try. And here's the solution. So I notice again it's that list of squareds, but it can't just be n squared, because if I plug in n equals 1, that's 1 squared, which is 1. The other thing you can't say n squared plus c where c equals 3, for instance, because if 1 squared plus 3, that equals 4. My first term is good, but my very next term, the -9, forget the negative for a second, I'll deal with that later. But 2 squared plus 3 is 4 plus 3, 7, not 9. So in other words, this does not work, the plus c does not work, but something with the n squared does sound right. The correct answer is that it's quantity n plus 1 squared. Think about why this works. If I plug in 1, then it's 1 plus 1 squared, which is 2 squared, 4. Then if I plug in 2, 2 plus 1 squared is 3 squared, 9. And we see that we're good now. The plus 1 kind of moves it ahead in the list of squareds, which is why that worked. Then for the negative aspect, we're starting with a positive and then alternating, meaning if n plus 1 squared is my first part, the negative part is just -1 to the n plus 1, or -1 to the n minus 1. That's the same thing. And there's my answer. So that was a bit of a challenge question, but hopefully that made sense. And that's all the problems I have to look at today. Thank you all for watching. If you have any questions, please comment below. And I hope to see you in the next video. Take care, and bye-bye.